What makes one unique from the other? And let's start by looking at the equations. A parabola has the equation of y is equal to a times x minus h quantity squared plus k. And that's a vertical parabola. And then we have x is equal to a times y minus k quantity squared plus h. And that makes a horizontal parabola. And either way, the vertex is just hk. Vertex is hk. We've seen that, right? An ellipse, you got x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Do you remember what's different if it's a vertical parabola? Because this one's horizontal. The a switches locations. So you have, say, x minus h quantity squared over b squared, y minus k quantity squared over a squared is equal to 1. Yep. And we say that that one is vertical because how does a compare to b? A is bigger. Yep. And so the center here is hk. And then we've got these hyperbolas. What makes a hyperbola, the equation, different from an ellipse? Yeah, you got positive and a negative. So we've got x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Remember if that one's horizontal or vertical? That one's horizontal. Okay. Why is it horizontal? Y is negative. And then we have y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. And that one is vertical because the y is positive. So we have three examples today, and we start with this big question. Which shape is that? Is that a parabola? Is it a hyperbola? Or is it an ellipse? It's not in the form of one of the equations, but does make one of those shapes. Spend about 30 seconds, talk with your partner, see if you can make a prediction of which shape it is and why. Talk, go. No, just I'm going catching here there. Okay, here we go. So which one is it? Hyperbola. Why? Excellent. So here's how we tell the difference. Look at this. Here you have a y and an x squared, or an x and a y squared. So if it's a parabola, you won't have both squares. Here you do have both squares. For an ellipse, you got x squared and y squared, and they're both positive. But for a hyperbola, you have an x squared and a negative y squared, or you have a y squared and a negative x squared. So as you look at this one, it's quite obvious that with the x squared and the negative y squared that this is a hyperbola. So you're going to have 6 questions on the test. The first 3 will be, hey, Here's a parabola, graph it, give all the characteristics. Here's an ellipse, graph it, yada, yada. Hyperbola, graph it, yada, yada. Then you'll have 3 more. And those other 3, you have to be able to figure out which shape is it. Okay, which shape is it? So this is that assignment that's really important that you try to lock in, and that part of the study guide you want to know. So we're going to go through it together today. It may look complicated, but fortunately, a lot of you guys have some really, really terrific algebra skills, and it's not going to be bad at all. And what we do is we recognize that all of these have what we call completed squares. So we're going to need to complete some squares here, and that's what we've practiced before we've done in this class. So I'm going to gather my terms, my x's and my y's, and I'm just going to factor out the common factor before I complete the square. What can I factor out of the x's? 9 times x squared minus 8x plus something. What can you factor out of the y's?
16.
I'm going to factor out a negative 16. And therefore I have a positive y squared and a positive 2y plus something is equal to 16. Is everybody okay with my algebra to this point? Okay, now we go ahead and we complete the square. Do you remember how to complete the square? We take this number and divide by 2 and then square it. So 8 divided by 2 is, squared is, if I add a 16. And we know if we add something to the left side, we must add to the right side. Or subtract from the same side, but we're just going to put it over there to the right side, okay? Now, we don't add 16 to the right side.
4.
Nope. 16 times 9. The true value of the 16 is 16 times 9. You see that? And 16 times 9, everybody knows is 144. So we're going to put that right over there.
Yeah, I did that right away.
What number do you add to complete the square here? 1. So we subtract 16. So you can see how pretty this equation looks. We've got 9 times x minus 4 quantity squared minus 16 times y plus 1 quantity squared is equal to 144. Ooh, nice. I got a couple completed squares. Now to get in the right form, I just need to divide by 144. So you can see how we tried to set you up in previous stuff to be able to remember how to do this stuff. I think that this unit works out pretty nicely for people. 9 over 144 is 16. So x minus 4 quantity squared over 16 minus y plus 1 quantity squared over 9 is equal to 1. Got my equation. Sweet. So out of the 8 points, that would be 3 points. Be able to recognize the shape, then go ahead and put it in the right form. Okay. Then you got to produce the characteristics. I don't tell you the characteristics for the problem. If I listed a symptom, you'd be like, oh, duh, I already know that it's a hyperbola, right? But I will on the first 3 problems, so you don't have to memorize those. So now you know it's a hyperbola. We're going to identify the center. Let's check. I think that video is restarted. Yep. So we got center, and then we're going to go vertices. We're going to go length of the transverse axis. We're going to do the foci and the asymptotes. All good? All right. What's nice about this is if some of you guys were trying to work on some of the homework, you're I don't fully get some of this homework, or I need a little bit of review, or I maybe didn't get a chance to start, we're going to review all 3 today. Hyperbolas, parabolas, and ellipses. We do these 3 problems. So if you are confused about any of it, now is the time to lean in the focus. Where's the center? 4, -1. So it's time to plot that. Notice that if there's a 16 under the x, how many units am I going to go in the horizontal direction? All the way out to 8, right? So I want to make sure I can see everything on this graph. So I'm going to make a 12 by 12 graph. Okay, and I'm going to go by twos. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. I'm going to plot that 4, -1. So over 4 and down 1. Remember, every tick mark is worth 2. Now, instead of listing all this stuff, what do I draw next? What? Box. Yeah, I draw my box. I go right and left 4, and I go up and down 3. So go to the right 4 and left 4, up 3, down 3. Sweet. I like hyperbolas. I think they're fun. I just think, like, you know, if people saw you graphing this stuff, they'd be like, holy cow, you must be really smart. It looks super complicated, but it's really not bad. I like the box structure. It helps me organize my work. And now, where do I put them? Do I put them on the sides of the box, or do I put them on the top and bottom of the box? Like, where do they even go? Sides, because the x is positive. So I'm going to put it there and there. I just draw my shape. The location of the vertices.
Positive and negative. No, wait. 0, -1.
Yeah, good. So the y value stays the same. It's the, so Allie, you were trying to think of the changing the x value, right? And we go 4 units in each direction from 4. So 8 and 0, exactly. Yep, there you go. Length of the transverse axis, that's the distance between these two vertices. Well, if we went 4 in each direction, then it's the distance of 8. For the foci, you have to find what value? C. What's our formula for finding C for a hyperbola? A squared plus B squared. A squared plus B squared is 25 squared is, so C is 5. Cinco de Mayo coming on up. 2 days after Kelly's birthday. Yeah, my wife has a birthday on May 3rd. Think about buying a really good, like, portable speaker, like one of those Ultimate Ears ones. Yeah, so we'll try. I don't know. All right, location of those foci. Just 1 unit further, right? So -1, -1, and then 9, -1. That worked out nicely, didn't it? And then for our asymptotes, we've just got what? We've got what 2 things do you need? Yeah, a slope and a point on that line. What's the point on the line that they both go through? Don't say 0, 0. Yeah, it's 4, -1. It always goes through whatever the center is. So 4, -1. And then the slope, it's always just looking at your box. What's the rise of the box? 3, and what's the run? So we've got y plus 1 equals plus or minus 3/4 times x minus 4. Right? There you go. Not too bad, huh? Sweet. Flip it over. "20 seconds. Talk with your friend. What shape does that make?" Go. All right, I heard it. I heard parabola. Why is it a parabola? It's only one that's squared. And is this going to end up being a y equals or an x equals? Y equals, because there's no y squared. So you're going to be solving for y. Before we do that, we need to complete a square for x. I'm going to complete the square. X squared minus 4x plus something is equal to 8y minus 28 plus something. What do we add to complete the square? 4. Yep. This is x minus 2 quantity squared is equal to 8y minus 24. It's not a bad idea to take the 8 out. It's just better to subtract or to add the 24 first. Now instead of taking an 8 out, we will divide by 8. And so you get 1/8 times x minus 2 quantity squared plus 3 is equal to y. Remember, I divide everything. You're okay with my 1/8 and my 3? Okay, so we know it's a parabola. Does it go up or down or right or left? Goes up, yep. And so we have our direction, which you already established is up. We have our vertex. We're going to have our axis of symmetry. We have our focus. Remember what else? The directrix and the length of the lattice rectum. All right, vertex. Two, three. And now is when I like to, as I know I'm going to make my scale, I actually like to think about my p-value here. Remember that we had that formula, A is equal to 1 over 4p. So my A value is 1/8 is equal to 1 over 4p. So what is p? P is 2, right? And so the length of the lattice rectum is the absolute value of 4 times p, or 4 times 2. So you're going to get 8. And that's going to give me a little bit of an idea of how big I make this graph. Because if I got to stretch it 8 units, that's how many units in each direction? 4. So if I got to go 4 units in each direction, then I should go all the way out to at least 6, right? So I'm going to make a 2 by 2 graph, and I'm going to go all the way out to 10, okay? So 2, 4, 6, 8, 10. That should be enough for me to be able to get a good picture of this. All right. Instead of filling all this out, I'm going to plot the vertex over 2, up 3. Who's going to judge me today? All right, Sophie, you can judge me today? 9 out of 10, or 10 out of 10, 9 out of 10, 2 out of 10, whatever. Okay. I'm going to try to do my best. Last hour I got an 8.5. So I had 2, 3, and then my axis of symmetry divides this perfectly in half. Draw my axis. I'm stepping in front of the board because I want to do a really good job. Nope, I don't want to. Focus point. What do I do for that? That looks confusing. What value do we need for these 3? Not C, but P. P is what? 2. So we're going to go 2 units up. Which brings us to what? What's that coordinate? 2, 5. And then for the directrix, I go 2 units down. And that's a line that's perpendicular to the axis of symmetry. Y equals 1. Sweet. And now the length of the lattice rectum we said was 8, so I got to go 4 units in each direction. Go to here. Go to here. Stretch it across. Then I'm going to draw my... Oh, wow, I already got a horrible from Allie. Okay, all right, so if you get to pick wherever you want me to pick a point on here. All right, we're going to see the distance from here to here. Should be the same as the distance from here to here. What do you think?
Not a shot.
Okay, all right, Maddie's already laughing at me. I compliment her on her eyes today and everything. And
Did not just count those too short. That is really good. I can't lie. That's so good. I was gonna be harsh, but I can't because that's really good. I'll give it a 10.1.
10.1, woo! Extra credit, let's go.
We don't believe in extra credit.
Exactly, I'll just take the 10. That's pretty good. I rocked that, I'm not gonna lie. Feel pretty good. All right, good. Last one, what shape? Ellipse, how do you know? Don't say because it's the only one we haven't done. Yep, one's positive and the other one's positive. So I'm going to factor out a 2 to get x squared minus 6x plus something. And then, is there anything to factor out of the y's? So I'll just write y squared plus 6y. And then I'm going to put the 26 over on the other side, make it negative 26. I love this problem. I remember when I made it up. I was super proud of myself. Nope. 9. So what do I have the other side? 18. Tricky, tricky. What do I add for the other one? 9. I used to have a German foreign exchange student. I'd say 9 a lot. 9! That means no. 2 times x minus 3 quantity squared. They didn't laugh at it as much as I was hoping they would. And then negative 26 plus 18 plus 9. 1. Whoa! It's equal to 1 already. Oh my goodness. But this is weird because ellipses, aren't they supposed to be like divided by something? Like, okay, so this one's divided by 1, right? But what about this one? Divided by half. X minus 3 quantity squared over a half. Plus y plus 3 quantity squared over 1 is equal to 1. Oh, yes, my friends. Yeah. Most of them, you know, a lot of them, you know.
You just like sit in your bed at night and you're like, oh my gosh, this problem to give them.
And here we are. Your brains are open.
Sitting in bed and he's like, oh my gosh.
I do. People should stop breaking my frames. Here we go. Center. Vertices. Major axis. Minor axis. Foci. And eccentricity. Yeah. Like I said, it's a good review in case you've forgotten anything. Where is the center? 3, negative 3. Let's go. 3, negative 3. If you think about it, look at the numbers that are underneath in x and y. The biggest one is 1. So that means we're going to move how many units in the y direction? Just 1. So if you notice, I've already made my quadrants here. I just look at the fourth quadrant. I can tell it's going to be the fourth quadrant the whole time. So I'm just going to do 4 tick marks. 1, 2, 3, 4. And let's see here. 3, negative 3. So over 3 and down 3. Right there. How many units in the x direction? Or y direction? Y direction. 1. So go up 1. I'll go down 1. How about in the y? How about in the x direction? The square root of a half, right? So the square root of 1/2, you guys recall, that's the same thing as the square root of 1 over the square root of 2, right? Or 1 over the root of 2, which is root of 2 over 2. If you did that in your calculator, it's about 0.71. So we go about 0.7 units in each direction. There we go. Now I can draw my bird's eye, whatever you want to call it. So are the vertices on the sides or the top and bottom? Top and bottom, because that's where it's stretched more. What's the location of those vertices?
3, negative 2. No, wait.
Yep. And 3, negative 4. Good. Major axis is the distance from the top to the bottom. 2. Distance of the minor axis is twice this. What is 2 times the root of 2 over 2? Which is the root of 2. To find, we're doing logistics. You just said, I'm just doing logistics. That's what you said. That's a good commercial. I like that. Yeah. Logistics. What's the company that does logistics? We'll look it up. All right, foci. Define foci. What's the equation here? A squared minus b squared is c squared. Which one is a squared? Is it the 1 or the 1/2? 1. The 1. So 1 minus 1/2 is c squared. What is 1 minus a half?
Half. So root of 2 over 2.
Root of 2 over 2 again. So that means whatever distance I went in the x direction, that's the distance I go in the y direction, which is interesting because if you look at those, that would make a perfect circle if you did that. It's kind of interesting. You don't have to use that. But so the foci, our x values stay the same. We're sitting at 3. But then from the center of negative 3, I go up and down the root of 2 over 2. And then how do we determine eccentricity? C divided by A. What is C? Divided by what's A? 1. So you get the root of 2 over 2, don't you? Have we seen that number root of 2 over 2 before?
Yeah.
Yeah, like if you're finding the terminal point at a 45-degree angle, right? Isn't that the root of 2 over 2? So sometimes every once in a while I'll get something on a test and you just tell it the problem is just too easy for some people. They come up with that and they recognize it, and so they'll like just leave like a little note for Mr. Gens. They'll say, well, Mr. Gens, I just happen to know that that's equal to the cosine of pi over 4. You know what I mean? And they'll give me a little happy face there, just like, hey, Mr. Gens, I got you. I know what you're looking at. And I'm like, oh, thank you. You know what I mean? Huh? I don't give extra credit for that. But I definitely get a smile. I'm like, oh yay! Like look at that. That's shows like you remember stuff. I like it. Phoebe? Yeah. Well, 45 degrees is not the root of 2 over 2. It's the cosine of 45 degrees. So like say you put a 45 here instead. Yeah, I go for that. Or what if you said, hey, I also know that it's positive in the fourth quadrant. I'm going to go 315. I'd be like, oh, Allie, yeah, you go.
What if I write something that's completely wrong? Yeah, what if I write like cosine of pi over 2?
then I would do this. I just, sorry.
Are you gonna dock? No, he definitely would dock.
Also,